Hey everybody, my name is Darwin. Welcome to another webinar. Today we're going to talk about basic data structures. So in your applications, when you use data, you want to choose the right data structure according to your needs. And today we're going to cover the basics. So we're going to talk about queues, stacks, lists, arrays, and associative arrays. So we're going to talk about them and when to use them. All right, so without further ado, let's go.
Okay, so let's see when to use these data structures. We've got queues, stacks, lists, arrays, and associative arrays. So I have this little window with every button that will take me to the corresponding data structure. And let's start with queues. All right, so here I have a very simple example. I have two different declarations. The first one, or the one that we're going to use, is this simple declaration. It's a queue of strings, uh, but you can declare queues of any type of variables. So what I have here, just for the sake of the example, is a queue of structures. So as you can see, I declare structures, a structure that contains a string variable and a datetime variable. And then I declare a queue of tasks. So it's a bit more advanced. However, for today, we're going to keep it simple and we're going to talk about a queue of strings. So as you can see, I have a series of strings that I have added to the queue using the enqueue function. And to remove the elements from the queue, I use the dequeue function. So first, this function removes the elements from the queue, and if the queue is empty, then the function returns false. All right. As you can see at the end, I wanted to get the number of strings that are still in the queue. So this will allow us to check if every element has been processed. Uh, so now, how does this work? Queues follow the first in, first out principle. That means the first element that is added to the queue is the first one to be processed, and then the first one to be removed from the queue once it's been processed. So first in, first out. This type of data structure is very common, for example, if I want to handle print jobs, multiple print jobs. So the first one that is sent is the first one to be sent to the printer, printed physically, and then removed from the queue. So this structure is useful when I want to process data in chronological order. Another example is that I have some resources and I have multiple access requests from different users. So I want to make sure that the first user to make the request is the first one to be served and then removed from the queue. All right. So when I want to process data in this order, queues are the ideal type of data structure. All right. So let's see the result. So I have the queue button, and as you can see, we have the different strings in exactly the same order that I added them to the queue. And at the end, I've got 0, which is the result of count. We wanted to know how many strings there were in the queue, and 0 means that every string was added to the queue and then dequeued. All right. So cool. Right. Mm, one important aspect of queues is that they can be used directly in multi-threaded programming. In this case, we need a slightly different syntax for the dequeue function. So let me go to the loop I have over here. So after the element that that holds the strings I want to dequeue, I'm going to insert a constant wait if empty, which will allow execution to wait until an element is added so that it can be processed, right? By default, there is no timeout, right? But we can specify one. So let's say, for example, 2 seconds, all right? So if after 2 seconds, no element has been added to the queue, the dequeue function will return false, all right? So it's very simple. When it comes to queues, first in, first out. Now let's move on to stacks, right? So as you can see, I have exactly the same 4 strings that I used for uh, queues, all right? But uh, unlike queues, stacks follow the last in, first out principle. So It's exactly the opposite, right? Here we're going to process the most recent element, the last one added to the stack first. And the terms also change a little bit. I'm not going to use the enqueue function, but push. And I'm not going to use dequeue, but pop. So those are familiar words for our developers, for all developers around the world. So um, we'll use the same syntax. As you can see, I'm just adding these strings to the stack, and I have a simple loop to pop them out of the stack, right? And in the end, I'm gonna check if I have any strings left. So let's see how that goes. Stacks, very good. So as you can see, we start with that longer string. So it shows us they were processed in the reverse order. And at the end, I've got again 0 to confirm that all the strings I added to the stack were processed and then popped, right? So uh, this is a very, very short introduction to queues and stacks, but basically they process data. Uh, so for queues, first in, first out. For stacks, last in, first out. Uh, that's basically all there is to it. So that's a basic overview of queues and stacks. Now let's move on to lists. Okay, let me open the code. Great. So lists are used to group a series of elements together to process them sequentially. The difference compared to queues and stacks is that you can read the elements of the list without removing them. So we're not going to be dequeuing and popping elements out of stacks and queues. We can read them following a sequence, and we can keep them there, right? So here I declared a list of countries, as you can see, and I have assigned the result of the country list function. I also used the continent North America constant to simply to narrow down the list of countries. Um, so then I loop through the list, and I want to get the name or to display the name of each country in a little trace window. So let's see how it goes. I click on list, and as you can see, I have the list of countries that are part of North America. Okay. Now let's go back to the code. Let's suppose that we want to add a country to this list. Okay, it's not going to be another country from North America, but we're just going to add another country. So I'm going to declare a country variable. I'm going to name it call, right? I'm going to use the country get function to with the ISO code for Colombia. So mm, country get, and I'm going to use C, right? And then I want to add it to the list of countries. So list of countries, my beautiful add function, and I'm going to add the call variable. Very good. All right, let's see how that goes. So I go to lists. So I have my list of countries, and as you can see, at the end, I've got Colombia. That's good. I have added the country to the list. There is one more, let's say, another possibility. And it is that I have the ability to insert elements at a given position, right, before or after the element I'm currently reading on the list, all right? So let me get rid of this for now, and I will take advantage of our for each loop to compare the word Colombia with the current country I will be reading on the list, all right? So if Colombia goes before the current country in alphabetical order, I will insert it into the list. Let me show you. So I have method over here, and I'm going to add a condition. If the name of my variable call, which is Colombia, uh, is less than mm, the name of the country, of the current country, right? Then what am I going to do? I'm going to go to my list of countries and insert. And here I have the constant I needed. I can insert after the current element, before the current element, at the very beginning of the list, at the very end of the list. So I'm going to use before current element, right? And what I'm going to insert is the call variable. Very good. And of course, once I have added it, I want to see it, right? So say, show me the name of the call variable. Very good. So of course, I want to insert it only once. Otherwise, it's going to be inserted before every country that goes after a call in alphabetical order. So to do that, I'm going to declare a Boolean variable right before the loop. So I'm going to name it country added, and I'm going to declare it's a Boolean variable. So I'll check that the country has not yet been added. And to do that, I will add a second condition. So I have the first condition, which is with the comparison between names. And I'm going to say also that I need to check that country added is false. This means the country has not yet been added to the or inserted into the list. Then I'm going to insert it, right? And once it has been inserted, well, I'll set the Boolean variable to true to specify that it has been added once, so I don't need it anymore. So I'm going to take country added. I'm going to set it to true. All right. This way, we check that we compare the name and we check that Colombia hasn't been added yet. Then we insert it at the right alphabetical order, and then we set the variable to true to tell execution, hey, it's been added. Don't insert it anymore, right? So let's see how that goes. So we're on list. And remember before when we added this at the very beginning, Colombia was at the very end of the list. Now let's see where it appears. So we're in our list, and as we can see, after Canada and right before Costa Rica, we have Colombia. It has been inserted into the list at the right alphabetical position. All right. So that's one more possibility of lists. So as we can see, lists are practical to store elements that are read sequentially. For example, you can store results of an SQL query in a list to read them afterwards. I didn't mention it, but if you want to, you can insert elements into the list, of course, but you can also delete one or all the elements from a list using the delete all functions. So let's say we take our list of countries, and I have these two very useful functions to clear the list if necessary or to delete given elements. So as with queues and stacks, lists can be used directly in multi-threaded programming, right? So concurrent accesses are not an issue here. Very good. So that's going to be it for lists. Now let's talk about arrays. Great. So arrays are another type of data structure that allows me to store elements of the same type, right? So I will have arrays of integers, strings, or other types of variables, but they have to be of the same type. But unlike lists where I have to read elements sequentially, in arrays I can access any element in any order, right? I can go to any specific element using an index, right? So that's what we have in the example right here, right? So let's say that in this case I declare an array of countries, right? I got again the result of the countries from North America, but instead of going from top to bottom, I want to go to the 10th country directly. So I do that using the index. All right. In this case, I declared a dynamic array. That means it's going to be generated from the result of the function, but I can also declare static arrays. That means I'm going to specify how large, how many elements are going to be in the array, and that's the case of this little declaration over here. I'll say it's an array of 15 integers, and that's it's as big as it gets, right? That's going to be the number of elements it contains. We can also declare multidimensional arrays, or in this case, two-dimensional arrays, right? And in this case, we access elements by specifying the indices within square brackets, as you can see over here, right? So this would correspond to rows and columns, all right? Mm, I can use this syntax, separate them with a comma, or I can also use uh, square brackets for each index, all right? To add, insert, delete elements, we can use the same syntax as in lists. Uh, so let me show you that. We have brief countries, and we have the add function, insert function, delete function, etc. You know, it's very, very standard programming. Um, I'm going to leave it there. Um, however, so adding, inserting, deleting, that's the same as in lists, but I have some other powerful options. For example, I can sort elements in the list. So let me show you the sort function. And then look at all of these possibilities. I can sort elements using different criteria. So I can use a case sensitive or insensitive sorting criterion. I can ignore or take spaces into account, punctuation, ascending the sorting order, etc. So I have many, many possibilities compared to lists, right? Um, so let's say you have written your own sort procedure. For example, you say, I want to uh, sort elements in ascending order. I want to ignore case, but take spaces into account, you know, to adjust your code to the needs of your specific project. If that's the case, you have declared your procedure, then you come here and you select AS column, AS, which stands for array sort. An AS function will allow you to use your custom sorting procedure or function, right? So you have many possibilities here to sort the elements of an array. Okay. Um, I previously mentioned you could access an element using its index, right? So you can also search for elements in the array using the seek function, right? So this is, again, offers us a lot of possibilities, search options, right? And once again, we have case sensitive, case insensitive, ignore accented characters, etc. Right? So you have all the possibilities you might possibly need in to do search in arrays. Okay, so uh, because of all of these possibilities, arrays are a very popular data structure. And compared to lists, you want to use arrays when you want to access a specific element, right? Without going through a list sequentially. So you want to go directly to a record or to an element. The arrays are the structure you should choose. And also when you want to sort elements, right? You want to reorganize them, rearrange them according to given criteria or your own criteria. Uh, so those are some of the possibilities of arrays. Now let's talk about multi-threaded programming. So in the three previous types, right, queues, stacks, and lists, we said there was no problem. Only one element is accessed every time. We want to make sure that, no, there are no concurrent access requests, but they are very thread safe. However, in arrays, if we are working with multiple threads, we want to protect data, right? And we'll do this using a critical section. So uh, we can do this in different ways. The first one is at the in the declaration of the array. I can use critical section, this attribute right here, and that means from the very start I have declared that this is a critical section. Only one thread can access this data at a time, right? You can also use critical sections within your code, right? Um, let's say well, the aim with this is to make sure the result of one operation within your code doesn't change before the next line of code is executed. So let's try a simple loop over here. So I'm going to use if array of countries is not empty, so empty equals false, then delete element number 1. There we go. So I'm checking that the array is not empty, right? And then I'm going to go directly to the element with index 1 to delete it. What can happen here is that if I have multiple threads uh, between the moment I check if the array is empty and the deletion, another thread might come in and delete the record I'm looking for. So in that case, my second line of code will throw an error, right? So uh, how can we avoid this? Very simple. I can go to the beginning of this section of code and say critical section start, and then the element I want to protect uh, between parentheses. Okay. Once I've gone through that section of code, I'll use critical section end, and then again the relevant element for this case, which is array of countries. All right, so we define a critical section around this section of code, and this way we can make sure that the array is not modified between the moment I check if it is empty and the deletion. All right, so that's how we protect, or that's how we work with arrays in multi-threaded programming. Very good. So let's move on to the last data type for today. Those are associative arrays. So in addition to all the advantages which you saw of standard normal arrays, associative arrays can be indexed using eh, any type of data, not only numeric data, not only integers, 0, 1, 2, 3, 4, but I can use other types of data. So in this case, we have a list of people, and instead of using indexes 0, 1, etc., we used their initials. So we used little strings, and that's what we're going to use to access the different records in the array. All right. So it's a very simple assignment, as you can see. Um, so we're using the initials of every person, and we access every element of the array using that key, right? So let's say I want to show one of these people in a trace window. So I'm going to go trace array of people, and then I'm going to say, hey, show me the element um, whose key is JS, right? Let's run our test. Associative array, and I get James Sunderland. All right, so that means I could access one of the elements in my array using that key, JS, and I got the value for it, which is James Sunderland. Good. All right. So this proves that we can access elements not only using numeric indexes as in standard arrays, but short strings. Now, these type of arrays do not support duplicate elements, right? So that raises some questions. What happens if I have two people or two or more people whose initials are the same, right? What happens if I try to insert new elements, in this case, new people, who happen to use the same or to have the same initials as the one that already exists in the array, right? Um, let me try that. I'm going to use a very useful shortcut, which is Control D to duplicate the highlighted line of code, and I'm going to name another person. Let's say Antoine Dotson. Very good. And let me change this to show you the relevant example. Right, AD. So what's happening here? I have two elements with the key AD, and I'm going to ask, right, or I'm going to open the trace window, and I'm going to show the element whose key is AD. So what's going to happen? Associative arrays, and I see Antoine Dotson. All right. What's the meaning of this? Right? We have Alberto Diaz would disappeared. As you can see, in the trace window, I was only able to see the last element that was added to the array. So I lost visibility over the other elements. Imagine we have 15 ADs, we could only see the last one. So this is something we need to address, all right? We'll go over the next lines of code and we'll come back to this. Um, Now, the second case is what happens if I try to insert two elements with the same key, right? So let's say these two records do not exist, right? And now I'm going to try to insert two elements, right? Um, all right, we don't need the trace at the moment. All right. So what are we going to do? We're going to run our code and boom, I get an error message. Say, hey, you called insert, right? But there is already an element for this key. So my array does not support duplicate elements as we mentioned before. And the code editor shows me where the error is. So it goes, I'll insert Alice Donovan, no problem. But then, hey, another element with key AD, I can't handle that. So it shows me where the error is. Now, worry not, we can find a solution for this, of course. This is one of the more powerful data structures, so of course we can handle this. All right, so if I want the array to support duplicates, I can simply specify that in the declaration. So what I'll do is go after array and say code completion helping me there with duplicates. Get rid of this. Okay, and now our array supports duplicates. All right. Um, let's test our insertion, right? Remember, we have this error on this line of code. Now, what's going to happen? I'm going to go associative array. We have no error message, which means the insertion was successful. Okay. Um, very good. Now, this line of code over here is no longer valid because now we're asking uh, we want to show in the trace window the element with key AD, but we have just inserted two, right? So what's going to happen? Okay, I get an error that says the syntax does not allow reading an element from an associative array with duplicates. So in order to show this, I need a different syntax. So what I'm going to do is look through the array. I'm going to say for each person, array of people whose key is AD, show me that person in the trace window. Very good. I can even include, the first two elements we had with key AD, right? So we're going to really check if duplicates are supported. All right. Let's run our test. Great. So look at this. Now, not only we can support duplicates, but we can show every element, those that were already in the array and those that I inserted. It doesn't matter if if they use the same key. All right. So just by declaring with duplicates, right? Just with this little um, addition to our declaration, uh, our associative array now supports duplicates. All right. So with this all of these possibilities, we wrap around our introduction to data types. So there you go. That's an overview of the most common ones. So we went over queues, stacks, lists, arrays, and associative arrays. So by choosing the correct data type from the start according to your needs, you can improve the performance and improve the readability of your code. So there are many options and functions we could not cover in this video. So please do not hesitate to refer to our online documentation to learn more about the relevant data type. Um, with that, I'll say thank you very much for watching. I hope you found this video useful. If you did, please don't hesitate to hit that like button and to share it with colleagues and developers around you. Uh, Thank you very much for watching the video, and I'll see you on the next one.